Hi everyone, this is Sri Chaitanya IIT Academy and we are to discuss JEE Mains 2021. So this is the first question. It's asking about catalytic reforming of alkanes. So what you have to do, this particular reagent will do aromatization and you have to make an aromatic compound containing same number of carbons, which is 7. So I get my answer 2. In the next question, this particular substrate will undergo hydrolysis, and at the end of hydrolysis we are going to get acetic acid. Then we have this particular reagent, and because of this SNI reaction will occur and it is going to give you an acid derivative, that is an acid halide. Further, you have this set of reagent which is nothing but Rosenmund reduction, and after reduction you are going to end up getting an aldehyde. So I get my answer as option 1. Next we have in line is a question. The keyword here it is will not yield. So whenever you are getting such a keyword, please do underline it. And they are asking which is not going to give you acetaldehyde. So when you look at option number 3, we have this particular reagent which is a strong oxidizing agent, So it is going to convert an alcohol into acid, into the corresponding acid. So here in this particular case, you will not get an aldehyde. So this makes my answer. Next, we have a question from biomolecules. They are asking about lactose and they are asking which is the linkage. Lactose is a polymer. Lactose is a polymer of when two units, one of galactose and other of glucose is connected. So let us look into the structure. So this is beta glucose, and I'm also making a beta galactose here. So this is the first carbon, and this is the fourth carbon of glucose. This is beta glucose, and this is beta galactose. So this carbon, which is the C1, and this carbon, which is the C4, they are connected by removal of a water molecule. So here, the fourth carbon of galactose and first carbon of galactose and fourth carbon of glucose, they are connected. So that makes my answer number 1. Next, we have two statements. An allotrope of oxygen is responsible for reducing smoke. No, it is a contributor of smog. When you go for O3, O3 is a component of photochemical smog. So first statement is incorrect. Second, we have oxides of nitrogen and sulfur are responsible for photochemical smog. Yes, it is partially correct as nitrogen oxides do participate, but not sulfur. So this makes the second statement also incorrect. So we have an option here for both the statements incorrect. Next, we have which of the following compounds are going to give sodium bicarbonate test. Here you need to keep in mind that those compounds which are acidic, then carbonic acid H2CO3 are going to react with NaHCO3 and produce CO2, and that CO2 is a colorless gas which is going to exhibit itself as an indicator in the test. So here we need to see which of the following compound is acidic then carbonic acid. This one is not. This one is because it's a benzoic acid. And again, we have this particular compound that is trinitrophenol. This is also acidic than H2CO3. So we have an option here, 2 and 3, both are going to give this particular test. Next, we have a question where we are going to obtain p-amino azobenzene. So what is this p-amino azobenzene? Let me make this compound here. So this is they are looking for. In the first option A, you see Stephen's reduction. So this particular reagent is going to reduce this NO2 group into NH2. Then you have HNO2 and aniline. Because of this particular thing, HNO2, what you're going to get, you're going to form a diazonium here. Now this particular diazonium is going to react with aniline again, and it is going to give you p-amino azobenzene. This is like an azodie test of diazonium. We look at option B, you have NaBH4. Sodium borohydride is also a reducing agent, but it is not capable of reducing NO2 into NH2. So in this particular case, you are not going to end up p-amino azobenzene. Let us look into option C. In option C, you have aniline, then we have HNO2, so you're going to get a diazonium. And then again, we have aniline, so it further reacts with aniline and produces this particular compound. So yes, A and C are going to give you the desired product. So here the answer has to be, if you look at the options, they are asking not formed. So A and C it's forming, so answer has to be B. In case of B, it's not forming. Next question we have addition of HCl over a pi bond. Now there are two different groups attached at the either ends of this particular ring. So carbocation formation will occur according to its stability. Now when this H plus get attached to either end, one of the end of the pi bond, a positive charge is going to form at the other. At this particular carbon, the positive charge is going to be more stable. Why? Because it is going to experience the plus M effect from the adjacent OCH3 group. Thereafter, Cl minus, which is waiting in the solution to attack, will attack at this particular carbon, and we are going to get this as a product. I'm sorry, there is no ring here. Now further, NaI and acetone, this is very easy. It's going to give you a substitution, replacing the Cl with iodine. So A here is a Cl here. I think this is my A, and B should contain a I. So this is my B. So 2 is the correct answer. Next, we have which of the following is true. So when you go by elimination, this becomes very easy, but if you go by theory, then it becomes very difficult. So Buna N is not a natural rubber, so I'll eliminate this. Neoprene is an addition copolymer. Okay, that is correct. But used in the bucket formation, that is incorrect. Buna S is a straight linear polymer. Okay. Thermosetting plastic. No, that is also incorrect. So I am left with only second option, that Buna N requires nascent oxygen during its manufacture. Next, we have a very straightforward question from metallurgy on, they're asking about the Lingam diagram. The Lingam diagram is basically a diagram between delta G of a process, which is an oxide formation process, versus temperature. So on y-axis, you have delta G, and on x-axis, you have temperature. So that makes option 1 correct. Now we have a solubility question. This is a difficult question in this paper, relatively, I'm saying. So they are asking the solubility of AgCN. So I'm going to write down the equilibrium between the undissolved and the dissolved parts of that particular salt. Now, Cn minus is a derivative of a weak acid and therefore it is going to undergo hydrolysis. That means what? Cn minus is further going to react with the water present in the medium and it is going to give you HCN plus OH minus. That means it is going to display its basic behavior. So this two particular process will occur and solubility will get affected. When the Cn minus is constantly removed from this equilibrium due to hydrolysis, the solubility is improved. So the straightforward formula, we can use it here. Solubility is equal to under root Ksp 1 plus H plus concentration divided by Ka. So Ksp value is given in the question 2.2 into 10 to the power minus 16. 1 plus H plus, the pH is given 3, so H plus is 10 to the power minus 3. What is Ka? Ka is 6.6 into 10 to the power minus 10. So you simplify this out and we arrive at something very close to 1.9 into 10 to the power minus 5. So that makes 1 as a correct answer. Now we have B2H6. It is a Lewis base. Now we all know it's not. So that's incorrect. Now what about others? All the bond angles are 120 in B2H6. No, it has a different kind of bonding, electron deficient bonding, which is called banana bonding. I'm trying to depict it. This way, it has a structure where we observe electron deficient bonding. Why I have showed it like this? Because these two hydrogens are above the plane and below the plane. Now this particular angle, let's say for example B, and this particular angle, let's say for example A. Now B is greater than A. Now we also know that S character is directly proportional to bond angle. Percentage S character is directly proportional to bond angle. So here we have more S character. That means what? In these orbitals, the P character will be less. So that makes my answer 2. They are asking about the probability distribution curve of 3s orbital. How to proceed these kind of questions? You have to just identify the number of radial nodes, which is given by n minus L minus 1. For 3s, the value of n is 3, L is 0, 1 is 1, so it gives you 2. So that means you should have 2 nodes between the nucleus and the boundary of that particular orbital. That means what? The probability distribution function should become 0 twice between the nucleus and the boundary of that particular orbital. So check. Now we have 2 and we have 4. Here it is getting 0. Here it is getting 0. Here also we have two situations where this function is getting 0. So either of this can be the answer. But then we also have to know that successive peak gets increased. So this is another information that will be valuable for solving this particular problem. Successive peaks increases. So we will stick to this particular graph because here the peaks are increasing. So that makes my answer 2. Next, we have a very simple question, H2O2 acting as an oxidizing agent. So straightforward, the answer is 1 because it is oxidizing I minus to I2, where iodine is present in 0 oxidation state. Next, we have what are the pairs having the same outermost configuration. So if you look at carefully, Cr plus will be having 3d5 configuration and Mn plus 2 is also going to have 3d5 configuration. So this is my answer here. Next we have, which is not possible according to MOT. So if you look at the options straight away, BE2 is there. What will be the configuration? Sigma 1s2 and then sigma 1s star 2. So here we have two electrons in the bonding and two electrons in the anti-bonding. So overall the bond order will come out to be 0. And if we have a 0 bond order, then the molecule doesn't exist. That makes my answer 1. This question is a little bit tough because people mostly ignore the lanthanoids part and the actinoids part. So I will not mind if you have skipped this question. But Sometimes it is a nice strategy to skip a question also. Statement number one, say cerium dioxide is used in the oxidation of aldehyde and ketone. Yes, it is a selective catalytic oxidizing agent, and at the same time EuSO4 is also a strong reducing agent, because you have to know about the data that EU plus 2, and if you compare EU plus 3, the stability of EU plus 3 is higher. So it will have a tendency to jump into plus 3 state, thereby reducing the other one. So both the statements here are correct. So option 4 is more appropriate. Next, we have two complexes. We need to tell their hybridization and magnetic moment. First complex, if I look the configuration of Mn plus 2 in the ligand field, that means in the Cn minus field. Now Cn minus is a strong field ligand. So we will do some kind of back pairing here. I'm solving the question as per VVT. So Mn plus 2 is going to have 3d5 configuration. Now when you start to back pair, you're going to arrive here. Now this is your 3D. For hybridization, you need 6 orbitals, because the coordination number is 6. So this is your 4s and this is your 4p. So from here, you are going to take 6 orbitals, which are going to participate in hybridization and thereby bonding. So this is going to give you D2sp3. Now, if you're having D2sp3 and an unpaired electron, the situation is what? Paramagnetic. Another one, Fe plus 3. Now, this configuration I'm writing again in the Cn minus field. So Cn minus is a strong field ligand, and therefore here also we'll be having some kind of back pairing. And the situation will look like this, because it is also having 5 electrons. Now you're going to take empty orbitals as per coordination number, which is 6, and we will arrive at D2sp3 hybridization. Here also we are having an unpaired electron, so it is also paramagnetic. There's a slight correction here. Make it D2sp3 and make this one as your answer. Next, we have Freundlich isotherm. Again, this question comes in almost every paper. So adsorption is directly proportional to P raised to power 1 upon N within intermediate pressure values. Not pressure is 0 and not pressure is extremely high. Within the intermediate pressure values, this is the situation. So we have option 1 is correct, N is little bit missing. So you please check it out. Now we have another question from stoichiometry. So we have a hydrocarbon which contains some oxygen as well. On combustion, it is producing 2.6 gram of CO2 and 1.08 gram of H2O. Now we need to find out the mass of oxygen in this particular compound. Now, what you do here, you straight away find out the moles of CO2. So that will be 2.64 divided by 44. So you are going to get here 0.06. Now again, in a similar manner, you can find out the moles of H2O, that is 1.08 divided by 18. And here you are also going to get 0.06. Now from here, we can get the moles of carbon, which will be same. Then we can get the mass of carbon, which will be 0.06 multiplied by 12, and that will be 7.72. Here we can get the moles of hydrogen atom, which will be double of this. So moles of hydrogen atom will be 0.06 into 2. Now we need to find the mass of hydrogen atom, that is 0.06 into 2 multiplied by 1. You will get this much mass of hydrogen. Now from the overall compound, the total mass was 1.8. If you subtract 0.72 and 0.12, you will get mass of oxygen atom. Now this mass will come out to be 0.96. They're asking percentage of oxygen. So what we do, we write 0.96 at the top divided by 1.8 into 100, and we arrive something close to 53%. Next, we have sp2 hybridized carbon in the final product. So we need to know about the reaction. So first is an aromatization process. Acetylene will get converted into benzene. And then we have CO, HCl and AlCl3. This is like hydroformylation. You're going to get a CHO group here. So you need to count number of sp2 hybridized carbon atoms, 6 in the ring, 1 outside, total is 7. This is a question from chromatography. Now they are asking the retarding factor. Two components of a solution are being separated in this way, and they are asking the retarding factor. What you need to know is that retarding factor is nothing but this distance divided by this total distance. 2 divided by 5, that will be 0.4. Next we have, which of the following do not hydrolyze? This is from P block, hydrolysis of halides. I can straight away pick the answer SF6 because I know it. Other compounds are hydrolyzed very easily. This is going to give you silicic acid and HCl. PCl5 will give you POCl3 and HCl on partial hydrolysis, but on complete hydrolysis, it is going to give you H3PO4. BF3 in a similar manner will undergo hydrolysis and it will give you H3BO3 and fluoboric acid, HBF4. Now, this fluoboric acid formation points us to the fact that it is undergoing partial hydrolysis. And SF6 do not even undergo hydrolysis because of a very stable geometry. And at the same time, fluorine is not a very good living group. So here, it does not react with water, no reaction. So in case of BF3, we are having partial hydrolysis. In case of SF6, no hydrolysis. HCl4 and PCl5, they undergo hydrolysis. So what are the conditions of hydrolysis? I'm talking about hydrolysis via SN2. So hydrolysis via SN2 takes place. The conditions are there should be a positive center at the central atom. The central atom should contain vacant orbital. And also there should be a presence of decent leaving group. If these conditions are satisfied, then hydrolysis occur or can occur via SN2 mechanism. Next, we have A2B3 is a compound which is 60% ionized. So let us write down A2B3. So if I write down the equilibrium here, 2A, let's say this is plus 3 plus 3B minus 2. If it is n naught initially at t equal to 0 till the establishment of equilibrium, of course, something is going to dissociate 2 times n naught alpha, and this one is n naught alpha. Now, if I'm going to find out the Van 't Hoff factor, what is the total moles at equilibrium? 2 plus 3, 5. 5 minus 1 is 4. So n naught plus 4 n naught alpha divided by initial moles 1 plus 4 alpha. This is the Van 't Hoff factor. Now they are asking the boiling point. So let us find out the delta TB, which is equal to KB. KB is 0.52 into I is 1 plus 4 alpha in this particular case, multiplied by molality. Molality is given 1. Now, if I go further and solve this one, I get TB. What is alpha? Alpha is 60%. So it is 0.6. 0.6 into 4, 2.4. This will be 0.34. So that will come roughly around 1.768. So we know the boiling point of the solution. Water boils at 100 degrees. So what will be the boiling point of this solution? 100 plus 1.768 degrees centigrade. Next we have, there's a tire. It's a ideal gas application question. The tire is considered a constant volume container where volume is constant. And since the tire hasn't burst or it's closed, total number of moles is also constant. You look at ideal gas equation, number of moles and volume, they are constant. So what is left? Pressure is directly proportional to temperature. So P by T is equal to constant. So when the pressure is 35 psi, the temperature is 300. So when the pressure is 40, what will be the temperature? Write it T. From here, you are going to get T, and T you will get 342. But they are asking the answer in degree centigrade. So from here, you subtract 273, and then you will get something 69.85 degrees centigrade as an answer. If you round it off, it will be 70 degrees centigrade. So that's it. Hope you have done well in this paper. Overall, my opinion is that it is relatively on the easier side, except you skip one question. And if you can keep your breath up, the paper is relatively easy. Thank you very much.